Hello again and welcome to another episode of Flip Chemistry. Today's class we're going to be learning about molarity and dilution. So hopefully in your journey of chemistry study you've been studying solutions and how to calculate molarity. So the problem for today: how would you make a 100 milliliter of a 1 molar copper sulfate pentahydrate, which is our solute water solution? So how would we make a concentration of 1 molar, but our volume is 100 milliliters, not a liter? So as some quick review here, some terms that you have to know. Molarity is equal to moles of solute, in this case, copper sulfate pentahydrate, divided by a liter of solution. So first, we have to figure out what is the molar mass of copper sulfate pentahydrate. This is a large molecule. Water is part of its structure, so you have to keep that in mind as far as molar mass goes. So what I've done here is I've first calculated the molar mass of copper sulfate. So copper is 64 grams a mole, sulfur is 32 grams per mole, and oxygen is 16 grams per mole, but don't forget we have 4 oxygens here. That's 64 grams. Taking the sum of our copper, sulfur, and oxygen, the molar mass of just the CuSO4 portion is 160 grams. But don't forget, water is part of that structure. So separately, we have hydrogen is 1 gram per mole, and there's 2 hydrogens, so that would be 2 grams, plus the mass of 1 oxygen, which is 16 grams. So 16 plus 2 is 18 grams per water mole, but we have 5 moles of water, so 18 times 5, it gives me 90. So I need to combine the masses of both the water component and the copper 2 sulfate component, which I've done here. 160 grams of copper 2 sulfate plus 90 grams of water equals a total molar mass of 250 grams per mole. So now, how do we make this desired 1 molar solution that's dissolved in 100 milliliters? Well, we first have to calculate our molarity here. So a 1 molar solution means you have 1 mole of solute per every 1 liter of solution. But if you recall from the last slide, I don't want a liter of solution, I simply want 100 milliliters of solution, or 10 times, or 10% of a liter. So I multiply it by 100 milliliters, which is equivalent to 0.1 liters. Okay. Remember, with molarities, we're dealing with volumes in liters. That's how the expression is written, not milliliters. So a note would be to always convert your volumes to liters. So 1 over 1 is 1, times 0.1 is, well, 0.1. So that would mean we would need 0.1 moles of copper sulfate. How many grams would that be? Because if I try to put 0.1 moles of copper sulfate on an electronic balance, the balance is going to give me grams instead of moles. So I need to convert my unit from the mole to the gram, in which the electronic balances read mass measurements. So I take my moles, 0.100 of my solute, times the molar mass that we calculated in the previous whiteboard piece. So 0.1, or a tenth, times 250, excuse me, would be 25 grams of copper sulfate needed. So we need 25 grams of copper sulfate. So 25 grams of copper sulfate is the amount of solute that you need, which is equivalent to 0.1 moles. And we're going to divide that by our volume. Don't forget, this is equivalent to the volume that I desired, which was 100 milliliters. Okay. Now to demonstrate that, I have that pre-measured. the camera's going to pick this up or not, but there's our copper sulfate. Okay, it's 25 grams. I've pre-massed this. And what I'm going to do is take my solute. Here's my 25 grams. Okay? That's my solute. But we need 100 milliliters of a total solution. So, here's my graduated cylinder with 100 milliliters. And I would stir this up. And make a solution. Now this is going to take a while to dissolve, but technically that's 100 milliliters of 25 grams, which is a 1 molar solution. Now there's a second problem here. Now, what if we want to take from the solution that we just made, our 1 molar solution of 100 milliliters, we call this our stock solution. This is what we're starting off with. Most high schools order chemicals from chemical supply companies, and typically if they're liquids, that's called the stock solution. They're usually concentrated molarities. Okay? You get more bang for your buck when you purchase that way. Let's say I don't want a 1 molar, 100 milliliter solution. I want a solution that's more dilute, okay? That simply goes from 1 molar to 0.2 molar. But I don't want to pour any water back into my stock solution. I don't want to touch this. Let's say I want to use this for later. So I don't want to dilute it because that would change my concentration. So the question is, how much of this stock solution that I have in my hand, how much of this do I need to pour into a new beaker that has 250 milliliters, or 0.250 liters, of this solution? So whenever you confront problems like this is called a dilution problem. So we're going to use the dilution expression, which is the molarity and the volume of the stock solution, which I know, equaled to the molarity in the volume of my new solution. Okay. So in blue marker here, I wrote V1 is blue because that's our unknown. So our new expression is the volume that we need to pour from my stock solution is going to be equal to M2V2, molarity and volume of my desired solution, divided by my my molarity of my stock solution. So let's see this setup. Okay, so this is our last piece of whiteboard here. So let's solve. V1 is going to be equal to the molarity of what I want to make, 0.2 molar, which should have a total volume of 0.250 or 250 milliliters, divided by 1 molarity, which is the molarity of this solution. So V1 says we need to pour 0.050 liters of our stock solution, or 50 milliliters. Okay, so and my copper sulfate needs to sit for a longer period of time. A lot of it is undissolved, but just for the sake of time, I'm going to pour this. So we need 50 milliliters of our original sample. So I'm going to pour 50 milliliters. That's my 50 milliliters. Okay. So we now want to make a molarity of 0.2. Let's put this previous pour it up here. So now I'm going to pour my 50 milliliters. So now we have 50 milliliters of a 1 molar solution. But if you remember, we don't want 1 molar, we want 0.2 molar. We want to dilute this. We want to add water. So if we have 50 milliliters of solution in there already, and we want a total of 250 milliliters, we have to add an additional 200 milliliters of volume of water to bring our total volume up to 0.250 liters. So I need an additional 200 milliliters of water. Finally, here's 100 milliliters. And here's a second 100 milliliters. Just going to max me out. And you can see the difference concentration. This is a 0.2 molar concentration. It's pretty light in color. And let's compare that to a 1 molar, which is 5 times as concentrated. 1 molar, and my left hand here, and 0.2 molar. Okay. Once again, thanks for watching another episode of Flip Chemistry, and I'll see you next time.